Hello and welcome to Patch Math, where today we are going to patch your math knowledge on surface area. Most notably, we will be looking at triangular prisms today and the difference between lateral surface area and total surface area. Now, let's just say we've forgotten all these formulas. How could we reconstruct them on our exam? That's where I want to dive into before we even look at the problem. The first thing is understanding what lateral surface area means, all right? So lateral means the total area of all the sides of the three-dimensional object excluding the top and bottom bases. So you have to know your geometric figures and what's defined as a base on them. So if we look at our triangular prism, the triangular part is our base. That can kind of get confusing based on how it's rotated. So that is the surface area that we are not going to consider. However, and it does occur on the top and the bottom, we need to know portions of that base in order to understand the height of each of our lateral faces. So that's going to be these rectangles that are, and I'll highlight here, that's going to be these rectangles right here that are formed by each side of that triangle. That's all we're finding. The area, all right, and the area of each of those rectangles. So area of one rectangle, area of the other rectangle, area of the third rectangle. And that's where this formula comes from, but it's not inherently, it doesn't look like it if we are not careful. Now, one of the things is that L, so they're calling the lateral edge, the length of the lateral edge there, that's going to be the same width for every single one of our rectangles. And so rectangle, the area formula for a rectangle is just length times width or height times length, however you want to say it here. And so what we're finding is here, this would be S3 times L would give you the area, and we'll call this a face 3, right? The area of face 3. Now, if we came over here, we got a rectangle that if we were to sketch this, and my geometric sketching is not the best, so bear with me here. If we were to sketch this very badly, these are just kind of like seeing this in the 3-dimension, right? All right, so you look down here, now we've got this S2, and that has the same lateral width, however you want to describe that, length width times the height, S2. So the formula for the area of face 2, and I can write it right there. No, that won't come through. Well, yeah, I can do that. The formula for the area of face 2 is going to be that S2 times the same lateral edge. And I'm using a cursive L there. Now, if we look over here, we have the same idea repeated, but for the height of S1, same lateral width. All right, it's that blue face right there. And I'm going to write this one off to the side so it doesn't get messy. This is going to be your area of your face 1, and that is going to be that height equals that height S1 times that same lateral edge. So we don't care about the area of the bases, but we do need to know a little bit about those side lengths in order to know the height of each of our lateral edges. You'll see here, each of these areas have one thing in common, that lateral and edge. So what happens is we know that if we were going to find the surface area of all 3 of those rectangles put together, we would add them together. So that would look like A1 plus A2 plus A3 there. That's just, and I'll even write this out front, side length 1 times the lateral edge plus side length 2 times the lateral edge plus side length 3 times the lateral edge. Got tongue tied there on that last one. And you'll notice that all 3 of those terms have a common factor, L. That's where this formula comes from. That L gets factored out right here. We'll go ahead and see L is right here. And that's where it came from with the leftover surf side length 1, side length 2. and side length 3. That's where that formula comes from. So super important. Now that we know where it comes from, let's go ahead and apply our formula, apply it to problem 3. So problem 3, take a moment, pause this video, read that. What you're going to see is it's just translating what we have here. In other words, we have our side length 1 and our side length 2. And our side length 2. And our side length 3. We've got our lateral edge of 16.5 meters. And so now we know we can take that lateral edge. Notice it's the same. I like the way they drew this one. It's the same height for all 3 of those rectangles. All right. And then we take that height times each of those side lengths to, they rotated it height, width. There's so many things you can call this. It's 2-dimensional rectangle. One of the dimensions is 16.5 for all 3 of the rectangles. Then we have different heights or widths, however you want to call that, for each of the rectangles. Looking here, we can go ahead and apply that. We'll just call that side length 1, 2, and 3 in the lateral edge, so that way we're not confusing length and width. Just note that's just the rectangular area of a rectangle repeated 3 times. And this formula right here makes it a little bit more simple. So I'm going to go ahead and snip this and bring it on down. So we know that we have it. Correct. This is lateral surface area. We all abbreviate it LSA. You're dealing with a word problem. We want to consider units when we're done. So we know we have side length 1, which is 5, plus side length 2, which is 8, plus side length 3, which is 10, times our lateral edge, which is 16.5. Type this into your calculator and you will be done. Now, if we have 5 plus 8 is 13 plus 10 is 23. We've got 23 times 16.5 here. All right. And then you can always use scrap paper if you need to. You know me. My student that I'm making this for, they're allowed a calculator tomorrow. I'm going to do a calculator for this part. 23 times 16.5. So 23 times 16.5 is 37. Why did I say 37? 379.5. All right. So we zoom out and we think about what are we dealing with here. Even though this is a 3-dimensional object, we are finding a 2-dimensional measurement, a surface area. So we are dealing with meters. This is meters squared. They also do tell you, or problem skills say that you want to mark what they're asking you to find here. First thing they did ask is for the lateral surface area in square meters, and notice they gave it to you there in square meters. Now we're getting ready to find what is the total surface area in square meters. All right, so I'm going to call it part 2 of this. It was part 1. Now we are on to part 2. What's super important is to understand how these 2 processes are different. If you'll see, our lateral surface area is literally this right here. All right, you'll notice we already did the trouble of finding the surface area of 3 of our faces. There are 3 lateral faces. So this is your lateral surface area formula that you can find right over here. Now, with that being said, they have a little bit of extra. They have plus base times height here. And we have to be so careful because height is not inherently given. If you look here at our original problem, you'll notice that they did not actually give us the height of either one of our triangular bases. They gave us 3 side lengths here. So when I was doing this problem during the lesson, I stopped here because this is where it gets a little complicated. This formula assumes you've been given height. However, if you've not been given height, we have a different formula for calculating the area of a triangle. And due to the difficulty of that formula, I am going to go ahead and put it in a separate video. So if you would like to learn how to do the second part of this problem, the total surface area of a triangular prism, which is not right, that's super important. That if we were given a right triangle here, we would, as our bases there, if we were given a right triangle here, we could easily use this formula because one of our side lengths would be the height. However, we cannot assume we were given a right triangle here. And if you actually do some tests with the side lengths, you'll see this isn't a right triangle. We can't separate it in half easily because it's not isosceles either. And we don't have either, we have 3 distinct different side lengths. So you'll be using what's called Heron's formula in order to find the area of those triangles, which for some of my students is like late algebra 2 pre-cal levels math compared to lateral surface area on this one. So completely different skill sets almost. So if you'll go ahead and join me there on the other video, I greatly appreciate it. Thank you so much for your time.